Hi, mining community. Welcome back to another episode of the Dig Deep, the mining podcast. And today's guest is Diane Mather, who specialises in tunnelling. And apart from working for Inland Rail as the design manager, she's also the chair for the Australian Tunnel Society. Diane was introduced to us by Michael Moore, who's obviously previously been on the podcast, as they both studied together at the Camborne School of Mines. And Diane has studied geology, geotechnical, and a tunnelling degree. So thought it'd be good to have Diana on the podcast to discuss all things tunnelling with an emphasis on mining and I suppose how they combine and interact. So that's welcome Diana to the podcast. How you doing, Diana?
Good, thanks. Rob, how are you?
Yeah, I'm good, thank you. I'm good we're recording this on a Friday, so good end to the week. So appreciate if you can give us a summary of your career. Obviously, going back from when you were studying with Michael back in those days, and just take us through your journey of your career, how it's progressed to where you got to today.
Okay, yeah. So I grew up in Cornwall, so surrounded by mining engine houses along the coast, and quite close to what were back then when I grew up in working tin mines of Wheel Jane and South Crofty. And I knew a few sort of family friends that worked at the mines and had quite an interest growing up because they were so close by on how sort of mining worked and geology. So that sparked my interest. And then I think I knew as I left school that I wanted to study earth sciences and mining engineering. And Camborne School of Mines offered that option and had still has a world-renowned reputation of excellence for engineering, particularly in mining engineering and earth sciences. And I really was inspired by that and wanted to be part of that school of excellence. And a lot of my peers shared that and even continue now. Like there's a lot of Camborne School of Mines graduates around the world, particularly in Australia, and share that passion, I think, for the successful engineering that's grown from that excellent foundation at Camborne. So I graduated, as you said in the introduction, with a broad sort of engineering foundation, which covered geology, mining engineering, geotech, rock mechanics, and tunnelling. And I graduated in '98. So I think at that time, there was a bit of a downturn in mining, not just in the UK, but worldwide. And a lot of my uni peers ended up going to offshore oil and gas, civil engineering, IT was quite popular then, and finance and other industries. But I was very fortunate to get a position down on the southeast coast at Folkestone on a tunnel boring machine wastewater project. And that started my career in tunnelling. So it began there, and then I worked for London Underground on the tunnels there for a number of years, and then with the big contractor, Balfour Beatty. I moved to Australia in 2005, and I've been really lucky to have worked on a number of tunnelling and mining projects. I think the multidisciplinary scope that I get involved in, having that great background with the great foundation from Camborne, I get involved in a number of projects in both infrastructure and mining across a number of disciplines. So not just civil engineering or not just concrete or lining design, like I get involved in the mechanical systems, ventilation systems, fire life safety. So it's really good. And I think that's what keeps me where I am now in those projects. So it's really good. One thing, I guess, tunnelling and mining, particularly in Australia, you don't always have a project in your home city. So my home city's Brisbane, but I've been extremely lucky that I've been able to, what we call in Australia, FIFO. So fly in and out of some of the best mining and infrastructure projects in Australia. So I've been involved with the Oz Minerals Carrapateena project, BHP Olympic Dam, A lot of the big tunnels, West Connect in New South Wales, Sydney Metro, Melbourne Metro, and as you said at the beginning, I'm now on the Inland Rail project. So it's pretty fortunate, had a good time and a lot of exciting projects.
Yeah, certainly. Thanks a lot for giving us an overview of your background and career. Wondering if you can just give us now an overview of your current role with Inland Rail, and then I've got some other questions, probably more related to mining as well.
Okay, thanks. My current role is design manager for the Australian Rail Track Corporation. So that's the rail track operator, and I'm currently involved, as you said, in the Inland Rail project, which is a public-private partnership. We're about to construct 1,700 kilometres of fast freight rail link, which will connect the east coast of Australia, so that's Brisbane to Melbourne via regional Victoria, New South Wales and Queensland. So my title is the G2H design manager. I look after the section of alignment between Gowrie and Helidon, which is in Queensland. It's one of 13 projects on the Inland Rail program, and my scope comprises 28 kilometres of tunnel, which goes through Toowoomba, which is quite a mountainous range out of the west of Brisbane. There's a 6.2 kilometre tunnel through the Toowoomba range, and 13 bridge and viaduct structures, which are also about over the 6.5 kilometre length. So yeah, it's a big scope, and the completed project capabilities will allow double stack container trains, which will be up to 1,800 metres long. So that's a large volume of freight, the equivalent of 110 large trucks. So that's pretty significant amount of freight, pretty big, yeah.
Yeah. Obviously, you mentioned you went to the Camborne School of Mines, which obviously is renowned for mining. What made you sort of go divert into the tunnelling route rather than maybe mining or geology? Was there something that happened that made you go down that route? Was it coincident that you went down there, or was it something you aimed for?
I think it was more coincidence. I think there's a lot of things that apply across the two disciplines. You know, they're quite similar, and some of the skills are interchangeable. I think I've just been fortunate that there's been big tunnelling projects around. I call them these mega projects, and yeah, I've done a lot of different roles, like I said at the beginning, and been involved in quite a bit of different scope. Yeah, it's opportunistic, I think.
Yeah, but like you said, obviously tunnelling projects, whatever project you're involved in, are mega anyway. So what are the main differences or similarities between sort of tunnelling and mining from your experience, and how would you say some of those actually combine, whether it's people's certain skill sets or the way they go about approach a project? Yeah, just wondering if you can share some differences or similarities.
Yeah, I think there's a lot of commonalities that do apply. I think the main difference in mining, particularly in construction of, say, mine declines and ventilation adits, and is that the mining design is temporary, or what civil engineers would class temporary. The design life is really sort of around the 25-year mark, whereas civil infrastructure designs are typically 100 years or even greater. Like there's some specs coming out now with 120-year design life. So that's very, very different. I think as well, mine production or mine development is often, particularly in Australia, in semi-rural sort of outback areas where there's not much existing infrastructure around, whereas tunnels, particularly road and rail tunnels, infrastructure tunnels, they're usually developed for the movement of people or goods So they're generally being constructed into cities which already have existing infrastructure. So already sort of congested underground with cable tunnels or services, sewer tunnels, or even other road and rail tunnels. So that is a big difference. And I think also the contracts are different, like the contractual and financial models. Civil engineering tunnelling projects, inland rail's a prime example. They're public-private partnership projects where, particularly in Australia, I think the contracts are more sort of production-based contracts, and they have like a scheduler rates payment. So it's just a different model there.
Yeah. Obviously, there's a lot of tunnelling in underground mining. If you're looking at logistics, moving a commodity or mineral across, I suppose, a large distance or a large area, what would you say a company or a particular project that, or someone that's actually managing that project, why would they determine to put a tunnel in? What are the reasons why they would put a tunnel in? Obviously, there's certain obvious issues if it was going over water, I suppose. Obviously, I'm not technical, so I'm just trying to, I suppose I'm trying to get an understanding of things that people may not know. Why would you put a tunnel in if you're between point A and point B? What are the reasons why someone would think about putting a tunnel in apart from the obvious?
I think if you're talking about using sort of what we call mechanised tunnel, so that's more like the big tunnel boring machines as opposed to more traditional mining methods such as drill and blast, it's a lot faster. You can get down deeper and quicker. It's easier to ventilate the drives. You have a lot less temporary works. You don't have sort of temporary propping. You don't have as much temporary work structures, and tunnel boring machines can operate continuously. And if you can get a good production rate, you can get 24/7 operations, which is really good for program. And I think also compared to drill and blast, because you're putting your lining in straight behind your tunnel boring machine, you get a lot less rock damage and overbreak. So it's really good from that perspective as well.
Yeah, and obviously that's from the mining perspective. What about from a logistical? Obviously you're working across from a point A to point B, and I suppose if I'm thinking about other countries around the world, maybe third world countries that need to implement new infrastructure, what are the reasons behind why they may put a tunnel in as opposed to not putting a tunnel in? What are considerations a project director would be?
Stakeholders. I know that putting roads in and doing a lot of acquisitions of properties and disrupting existing road and rail networks can be reputationally bad for tunnelling contractors, and also quite disruptive to stakeholders. And I think more and more the community gets very sensitive to tunnelling projects or any kind of construction projects. I think when you close a road or when someone's got an excavator, whether it's a road tunnel or a water tunnel, disruption is always sort of hard. And like I said, I think earlier, there's not much room now to construct, 5-lane, 3-lane, 4-lane, 5-lane roads. In Sydney, they've been building a connection, the WestConnex tunnels, and those are up to four lanes. And it's a great way of putting in a 4-lane highway without sort of, ripping out people's houses or going next to local schools or extending more already congested roads.
Yeah, so I suppose it's easy accessibility if you're going from point A to point B without the least disruption. Like you said, going over particular land, you can probably have a tunnel if it has to go through houses, for instance, a particular line,
yeah.
it's just making minimal disruption on
Minimal
land.
disruption.
Yeah, understand.
Yeah. But like you said, you can also do crossings of water, like Sydney Metro's crossed from Barangaroo to Blues Point to get under the Sydney Harbour. The Cross River Rail Tunnel that's currently being constructed in Brisbane is one of 2 tunnels that will go under the Brisbane River. Crossrail in London and the Jubilee line in London's got a number of sections that make crossing the Thames really efficient.
Yeah.
So it is good for that.
Yeah. So what do you think tunnelling has learned from the mining industry from your point of view?
Oh goodness, there's a lot of good things I think that have been adopted by the tunnelling industry from mining, but particularly here in Australia, I think the instrumentation and monitoring and geological mapping that's been used in mining has been implemented in tunnelling, not in exactly the same form, but has been used and adapted to support what in tunnelling is known as the observational method or observational approach. And a good thing I think that I've seen come out of that is the use of trigger action response plans. So the mining industry is good at setting up their instrumentation and monitoring, and when they get alert or alarm levels, responding to those and having a set of prescribed actions that they take in the event of monitoring alarms going off. And the tunnelling industry has adapted that and used that to engage with a number of stakeholders. So where we are tunnelling over maybe under heritage buildings or sensitive stakeholders, areas that are subject to settlement, these trigger action response plans have been used for stakeholder engagement and community engagement to use like a risk-based approach to give comfort to the community that tunnelling is safe, and should anything happen, people have visions of big tunnel boring machines going through and then crater-sized sinkholes turning up in their garden. So these tools have been used to sort of overcome that bad news story and risk and cover that risk. So that's a good thing that that tunnelling has learnt from mining.
Yeah. Around technologies, what technologies and innovation do, I suppose, mining and tunnelling have in common? And what can each industry learn from one another?
I think a good thing, or a more recent thing, that both industries are using more and more is sort of spatial data visualization. So the use of LiDAR data from like satellite surveys, drone surveys, and geographical information systems, GIS systems. They're a really good integral tool. Mining's using them a lot more to sort of solve issues around location and accessibility and getting to ore bodies in a sort of more direct and safer way. And tunnelling are using them as well, more for monitoring and stakeholder engagement, a bit similar to what I spoke about before, but also being able to put some of this imagery on the web. And so when tunnelling projects are progressing, GIS systems are able to be accessed on the website of projects. Cross River Rail's got one in Brisbane, and you can log on, anyone can log on, any member of the public, and you can see where the tunnel boring machines are at in real time. And so if you do believe you're asleep at night and you can hear the big rock chomping monster underneath your property, you can see if it's there or it's 20 k's or 20 miles down the road. So that's been a really good tool. So that's good, and I think both industries are using that. Autonomous vehicles and drivers. Mining's really sort of taking the lead in that compared to tunnelling. A lot of mines now are using autonomous vehicles, not just for the movement of product, but also for operations and development. And modern mining drilling systems can be operated from like a single control point system where several drill rigs or bolters can be operating at one time, and you don't necessarily have personnel underground. Tunnelling's yet to get that. It's getting better, but we still seem to have quite a few underground activities that maybe if we could take on that automation, you could operate things from a single portal or a single place and streamline some of that, particularly for what we call sequential excavation, where you've got multiple headings in tunnels going on at one time.
Yeah. Also, you mentioned automation. What improvements would you say you would like to see within underground mining and tunnelling from your perspective and from what you know, how some of the underground practices have been going? Apart from automation, is there any kind of methods that you feel could be used to improve tunnelling or underground mining at all?
I think the use more of drones or on-vehicle monitoring equipment for operations and maintenance. I think we're getting there for survey. We're getting there for our geotechnical or geological surveys. We're getting there for with the LiDAR surveys and our hydrogeology contours and things like that. But the use more of drones for some of those like really tricky confined spaces, high access, difficult access areas such as ventilation adits or low point pump sumps and things like that. I think I'd like to see less people going into confined spaces and plant rooms, substations and things like that underground, and the use of drones and cameras for inspections and maintenance activities.
Yeah. So is these improvements related around risk to people?
Yeah, I think, health and safety and risk to people, and just taking the frequency out of people having to go into high risk areas. I think if you can do that autonomously, that it's a great improvement. And because drone cameras and things are getting so good now, and the computers are getting good, and most people have phones and iPads, you can almost have someone up on the surface having a look at things. That's not to say you never have to go down, and if you need to do some corrective maintenance, you need to go there, but maybe some of the inspections could be done that way.
So I suppose less time down underground, maybe less people but less time, as opposed to constantly being down there. Obviously some activities, not all activities. It's
not suitable to all activities, but there's some activities definitely.
As you're involved obviously in the transportation industry, what challenges are mining companies facing around the transportation of resources around the country, or even internationally?
I'm quite new in the heavy haul freight sector. I mean, Inland Rail's the first project I've done in this space, but the challenges that I think I can see currently in other countries is the ownership, operation and oversight of that freight logistic chain or supply chain is fragmented. Like there's a mixture of mining companies, government organisation, private providers, privatised railways. So there's lots of different people involved. The mine may have a contract with the rolling stock operator and probably has a contract with the port, but doesn't have a contract with the network rail operator because they have a contract with the rolling stock operator. And so it's very difficult. You've got multiple parties involved. They've got no direct commercial arrangement, and they're all driven by different KPIs or different objectives. And that I see that as quite a challenge, or that's what I've seen since I've become involved. And I think to be successful as a major resources producer and exporter, you need to transport large volumes. And so to do that is, and particularly in Australia and Europe, it's large distances, often from remote locations. So, you need to do that by rail. But yeah, it has a lot of challenges from what I've seen so far. Yeah.
Being a recruiter myself, I've worked in the consultancy space in terms of sort of management consultancy. So maybe a solution to the problem could be obviously you're adding another stakeholder to already a number of stakeholders, but it'd be one stakeholder that will set the KPIs and manage all the other stakeholders. So you're all working from one framework. I take it maybe has been done before.
I don't know.
Okay.
Possibly, yeah. I don't know.
And the reason why I suggest that is because I've recruited in that space where I was recruiting for a management consultancy or an engineering consultancy that stands in the middle between maybe the client and the contractor that are doing the work, whether that's build work or whether it's civil infrastructure work. But obviously this would be on a larger scale and probably more stakeholders, but it'd be one centralized body that everyone feeds into that sets the parameters. Obviously, it takes a lot longer, but at least everyone will be singing from the same hymn sheet, I suppose. So that might be a suggestion. I don't know.
Sounds good.
Do you think tunneling will become more used in the mining industry in the future? And I suppose obviously in underground, yes, but
I think so. I mean, there are a number of mines that successfully have used the mechanised tunnelling. Grosvenor in Australia and Stillwater, they're well known for using mechanised tunnelling machinery. TBMs they have some restrictions that don't make them as sort of user-friendly for mining. I mean, they're well suited for long, straight tunnels, so they're good for mine access tunnels and exploratory tunnels and ventilation tunnels. But yeah, you can probably only have a 300 metre, like you need a 300 metre turn radius, which is really big, whereas you see some of those mining declines that are quite tight and they can get as small as a 20 metre turn radius. So, there's a big difference there. If you're buying a mechanised tunnelling machine, you want to use it really for its usable life. It's a big long lead time procurement item, and it takes a lot of capex to buy it. So you'd really want to use it multiple times, and maybe that's what puts off mining companies compared to drill and blast, because then you've bought this bit of kit and you need to you need to use it. But they do, as I said earlier, that you get a good faster advance rate. You've got good precision. They're better for ventilation. You get a good smooth tunnel profile with less overbreak, and you don't need as much support. So yeah, that's good. I think Stillwater, they use their TBMs to get down into their mine declines, like their men and materials declines, and they got it when they moved from drill and blast to mechanised tunnelling. It was about a 30% saving, capex saving on that. So that was good, but it also reduces workforce because you just have one or two TBM crews, so it's less workforce intensive than drill and blast. But I think to get that faster advance production rate, there's a big learning curve, for the mining industry to train that workforce or to bring that workforce in. So maybe that puts people off as well. Not sure.
Okay. As a conclusion, just wanted to give us an overview. Obviously, you're the chair of the Australian Tunnelling Society. So I wonder if you can tell us a little bit more about what the society does, and I suppose how it could potentially help mining companies as well.
Yeah, so I'm the Queensland chair of the Australian Tunnelling Society. So we have 5 chapters, WA, Western Australia, Queensland, New South Wales and Victoria. And then we have 2 special interest groups within the Australian Tunnelling Societies. We have the Australian Shotcrete Society, and then a more recent group, which is a Women in Tunnelling group. We're a technical society of Engineers Australia, but also a member group of the International Tunnelling Association. So that's good. There's various technical societies within Engineers Australia, and obviously there's a lot of international groups within the International Tunnelling Association. We're different to a lot of other technical societies because our members and sponsors are quite mixed in discipline. I think that's because tunnelling has all the various disciplines in it, but we're also, for a technical society, not just engineers. We've got a real broad membership, corporate and individual membership and sponsorship base that represents all of industry. So we've got suppliers, designers, consultants, contractors, academics, engineers, scientists. So I think that's good, and that's good as well for the mining industry, because a lot of, like we've said throughout this chat, a lot of the things overlap. So I think for some of the suppliers and smaller subcontractors, specialist consultants that are involved, it's good for their networking because it's almost one place you can go, and they can build good networks there and share information. And I think for Australia, it's sort of the voice of industry for tunnelling, and we have actually had quite a few mining people come to our regular technical sessions and one-day workshops. The team at Grosvenor, when they were looking at getting their tunnel boring machine, which they did, they came to a number of ATS courses and workshops and got involved so that they could meet people in the industry and meet the different suppliers and get involved, and that's really good. So that's what we offer.
Yeah, no worries. Diane, I really appreciate your time in talking to us about, obviously, tunnelling. Obviously, a lot of the audience here listening are from the mining industry, and there could be various people listening, from very senior people down to graduates. If any of our audience is thinking about it, and I suppose if it's more senior people, if they're looking at their projects and thinking tunnelling could be an option for whatever reason, they may be faced with a particular challenge and they might want some questions answered. Hopefully they'll be able to reach out to you and you can probably give some advice. So I just wondered how our audience can sort of reach out to you if they've got any questions.
Absolutely. Yep. I'm on LinkedIn, so you can check me out on LinkedIn, and the Australian Tunnelling Society website. We have all the committee are listed on there. So yeah, there's multiple ways of getting in touch, and happy to answer some tunnelling questions.
Yeah, so I'll include those in the show notes as well. So if anyone's listening that has any questions, that may be looking at sort of tunnelling options, depending on obviously what challenges they're facing, then I'm sure Diana can answer any questions or queries that you may have to make you make a decision if that's the way you want to go. So really appreciate your time again. For those that are listening, appreciate if you can share this episode amongst friends, family, everyone else in the industry. We want to get this podcast out to as many people as possible. Obviously, it's an educational tool. People that are on this podcast are providing a lot of energy, a lot of content around particular specializations. And if we can get this out to more and more people within the industry, I think it will enhance people's education and understanding of the wider mining community. So appreciate, keep sharing and liking this. If you're watching on the YouTube channel, appreciate if you can like and share below, so it goes out to more people, so more people can access this content. So Diane, I really appreciate your time again.
No problem. Thanks for having me.
Chatting. No worries, great chatting to you. And those are listening, until next time, happy mining.